Good morning, physical science students. April 6th, 2020. It's Mr. Lambert here. I hope everyone had a great weekend. Let's get right down to it. Last week, we learned about speed, different types of speed in the world of physics. We learned that speed equals distance over time. Average speed is typically calculated as distance divided by time with a unit, something similar to this, like meters per second, distance divided by time. I wanted to introduce velocity today. Velocity and momentum is what we're going to be learning about, and then we're going to answer just a few problems from the posted text. Velocity is not much different from speed. However, it includes another piece of information. The textbook, which I want you to read pages 51 to 55 today, the textbook talks about how if there was a hurricane coming toward us, we would want to know a couple things about that hurricane. Not only would we want to know how fast it was going, its speed in meters per second, or maybe kilometers per hour, but we would also want to know the direction that it was traveling. So let me get my head out of the way. The only difference between speed and velocity is that velocity includes the direction of the object's motion. It includes speed and the direction. I gave a couple examples down below here. An example of a velocity would be 5 meters per second, similar to speed, but I included the direction, north. It doesn't always, the unit doesn't always have to be in meters per second. I gave another example, 48 kilometers per hour, but I included the direction east. Also, in order to calculate velocity, we're still going to use the same formula as we did for speed. Velocity is also going to be calculated, let me bring this down, as distance divided by time. But as you can see up here, we're going to include the units, but we're also going to include a direction. So another good example of the difference between velocity and speed, picture a race car going around a racetrack. Let's just assume that the race car is going at a constant speed, which means the speed is not going to change. Let's say 100 kilometers an hour, but it's not going to change its speed. If you've ever seen a race car going around a racetrack, what is that race car almost constantly doing? It's not changing its speed, but it's changing its direction. So even though the speed is not changing, in the world of physics, we say that if an object is changing direction, its velocity is also changing. Okay, the other concept that I wanted to mention today and introduce today is the concept of momentum. I'm sure you've heard the word before. As a sports fan, I always think about sports contests where one team gets the momentum over another team and the contest starts to swing the other way. In physics, here's the definition. It is the product of an object's mass and its velocity. When I say the term product, you should be thinking multiplication. Here is the equation. P stands for momentum. M stands for mass. V stands for velocity. So if we multiply an object's mass times its velocity, if we multiply the two, we'll get its momentum. We can calculate that. I'm going to show you a quick example problem so you can see units and how to calculate momentum correctly. Okay, sample problem that deals with momentum. Here's the problem. The question, what is the momentum of a car with a mass of 1,300 kilograms? Notice kg. That should tip you off. That should give you a clue that that is a mass. There's our mass right there, folks. What's the momentum of a car with a mass of 1,300 kilograms traveling north at a speed of 28 meters per second? Notice the word speed is used here. You have a unit of distance divided by a unit of time. There's the speed. But what else was included? the fact that it was traveling north. So all of this information right here, that tells you the car's velocity. So we have both measurements that we need. And the definition of momentum is the mass times the velocity. There's our mass, 1,300 kilograms. There's our velocity, 28 meters per second north. We simply need to multiply the two. I had to find my marker. Momentum, mass times velocity. There's our mass. P equals 1,300 kilograms times the velocity, which is 28 meters per second north. We're going to multiply the two. I already have the answer written down. If you multiply those two, the momentum equals, I'm going to bring this down. The momentum equals 36,400. But what? There's no special unit for momentum. You simply are going to use the two units that you multiplied together. It's going to be kilograms, which is your mass, times your velocity, which is a unit of speed plus direction. The momentum for this car is 36,400 kilograms times, there it is, meters per second north.